Alright, let's solve this differential equation. X to the power of 6 plus y to the power of 6 dx plus 6x y to the power of 5 dy equals 0. Now I'm going to solve this equation with the exact method, but I'm not going to be going in extreme detail. If you want to know the exact reasons behind each step, I posted a link in my description under this video, and over there I solved another exact problem with a lot of details, and you could understand the meaning behind each step much better. Here I'm going to be going through it faster and just explaining the solution. Alright, let's get started with our problem. First up, I'm going to multiply this equation with 1 over dx. Therefore, I'm going to get this one to come under this. Here it is. And now I can designate this as my m and this as my n part of this exact equation. Well, so far we just assume it's exact, but let's check. This test is what will tell us. First, we're going to take partial derivative with respect to y of the part m, and that's going to give us 6y to the power of 5. Then, partial with respect to x of the part n. It also gives us 6y to the 5th. Since these two are equal, that means the equation is exact and we can proceed with solving it by the exact method. Okay, let's continue the problem by taking an integral of the m part with respect to x. We're going to plug in this into our integral, then solve it, and we get 1 over 7 x to the power of 7 plus y to the power of 6 times x plus h in terms of y. Now, since we took an integral of this with only respect to x, therefore we're going to have a function left over which is in terms of y. Next up, whatever we found here, we're going to take a partial derivative of it with respect to y. Partial derivative with respect to y, plug in everything we found here, and we get 6y to the power of 5x plus, well, we have no idea what's the derivative of this, so we're simply just going to mark as hy derivative. Now at this point we need to know that whatever we got here is the same thing as the n part from our original equation. Therefore, we are able to put them equal to each other. So our n in the original equation that we had was 6xy to the 5th. We can put it equal to what we got here. There it is. We're going to simplify, and we're able to find that h derivative y is actually 0. Now we can come back to this equation that we have found here, and we can update it with the new information, which is this. Now this is the derivative of this, but what is the derivative of something that is equal to 0? It's a constant, right? So instead of the h, we're able to plug in a constant. I'm gonna use k. Now from the definition of this method, we know that this function at this stage is equal to a constant. Therefore, I can just simply take this constant to the other side and combine the two constants, and that will give me the c. This is why I didn't want to use the variable c up here, so I can use it in the final form, because we are always used to seeing c as a constant. And this is our final answer. 1 over 7x to the 7 plus y to the 6 x equals c. This is a good enough answer, but sometimes they want us to express y on its own, so therefore we can simply solve for it, and we can get a root of 6, and inside c over x minus 1 over 7 x to the sixth. And there you go. This would be our final answer for this exact differential equation.